Okay, in this video, this is just a review of solving trig equations. And those of you who are in class, this is just, as I mentioned, review. Okay, those of you who are not, you might benefit from this a little bit more. Okay, so there's some general guidelines to solving trig equations. If you see a single trig function, you want to isolate it. Okay, so it's kind of like solving one-step equations, right? If you see a single x, you want to get it by itself. You can also use square roots and factoring, so all your quadratic equation skills still apply to solving trig equations. Sometimes you might see different trig functions, like let's say you see a sine squared and a cosine squared. Well, what you want to do is get that all in terms of one trig function. In this case, you need to use your trig identities, right? Sine squared plus cosine squared is equal to 1. So you can transform that into one trig function. And last but not least, this is probably the most difficult example I'll say for the last. It's when you see two non-square trig functions and a non-zero constant, what you want to try to do is to square both sides. Okay, so that looks very convoluted. I'll talk about that on the last example. Okay, so let's start here with example 1. Find the solutions on the interval from 0 to 2 pi, non-inclusive for 2 pi. And find a general solution. The general solution just means find all the solutions to a trig equations, because trig functions are periodic, which means they go on forever, and technically you can have an infinite number of solutions, right? Okay, so on this one right here, right, 2 cosine x is equal to -1. We are going to use guideline number 1, which is basically isolate cosine x. So you could do that really quickly. You're going to get cosine of x is equal to -1/2. And now you're just solving a trig equation, given the fact that this number right here, right, this x value is on your unit circle, right? Whereas cosine negative, it's negative in quadrants 2 and 3. And if you memorize your unit circle, right, you're going to get x is equal to 2 pi over 3. Or x is equal to 4 pi over 3 in quadrant number 3. Okay, so this would be the solutions on the interval from 0 to 2 pi. So there's part 1. And then if I want all the solutions, right, for 2 pi over 3, which is right over here, right, this is my 2 pi over 3, it's going to go around the circle infinite number of times, right? So if I keep adding or subtracting 2 pi, all the solutions for this particular x value would be 2 pi over 3 plus 2 pi n, okay, where n is an integer, or x is equal to 4 pi over 3, right? 4 pi over 3 is somewhere over here, right? From this solution, right, it's going to go around the circle infinite number of times, and I just write plus 2 pi n. Okay, so this would be your general solution, and this would be your specified solutions on the interval from 0 to 2 pi. Okay, so example 1 was using guideline number 1. Let's move on to example number 2. Looks like we have a square here. Same concept, right? I see a single trig function. I want to isolate it. Sine squared x is equal to 3 over 4. Okay, if I add 3 and divide by 4, I'm going to end up with this. And of course, you can take the square root of both sides to get sine x by itself, right? So recall, right, sine squared x just means sine of x quantity squared. Okay, so if I want to get sine x by itself, take the square root of both sides. You're going to get sine of x is equal to root 3 over 4. Now, root 3 over 4, if I simplify it, right, the square root of 4 is 2. And also keep in mind, right, you have to write plus or minus. Sine x is equal to plus or minus square root of 3 over 2, right? When you solve square root equations, you have to put plus or minus. And I explained to you guys why that is, right? X squared is equal to 9. If you square root both sides, right, it has to be plus or minus 3, right? Because x could be positive 3. 3 squared will give you 9. Negative 3 squared will also give you 9. Okay, so don't forget to write the plus or minus. And now that you have sine x is plus or minus square root of 3 over 2, right? You can write sine of x is equal to root 3 over 2, or sine of x is equal to negative root 3 over 2. Okay, so where exactly is sine positive? Sine is positive in quadrants 1 and 2, right? So if you write sine of pi over 3 for quadrant 1, x is equal to pi over 3. For quadrant 2, x is equal to 2 pi over 3. Over here, where is sine negative? Sine is negative in quadrants 3 and 4, right? So for quadrant 3, you're going to have x is equal to 4 pi over 3. And for quadrant 4, you're going to have 5 pi over 3. Okay, so these would be your specified solutions on the interval from 0 to 2 pi. And instead of writing, so for part 2, right, you could write pi over 3 plus 2 pi n, 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, 5 pi over 3 for 2 pi n, right, based on this first example right here to give you the general solution. I want you to take a look, right? Here is pi over 3. Actually, let me erase that. Pi over 3 would look something like this, right? And this would be 2 pi over 3, right? Okay, so it's symmetric, right? Now the distance from here to here is a full pi, right? So instead of writing pi over 3 plus 2 pi n and 2 pi over 3 plus 2 pi n, what you could just write is x is equal to pi over 3 plus pi n as a way to condense the solution, right? Because this is a full pi between these two guys. So you don't have to write pi over 3 plus 2 pi n, 2 pi over 3 plus 2 pi n. Likewise, for these two guys, right? 4 pi over 3 is right here. And 5 pi over 3 is right here. If I go around the circle of full pi, right, I'm going to end up over here. And so, if I keep going around the circle another pi, it would end up over here. Keep going around the circle by a full pi, end up over here. What you can do is to condense these solutions. You could say x is equal to 4 pi over 3 plus pi n. Okay, so this would be the general solution to this particular equation. Now, if you write pi over 3 plus 2 pi n, this 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, is that wrong? 5 pi over 3 plus 2, it's not wrong. It's just when you look at the solutions in the back of your book or any math textbook, they will condense the solutions. And if I give you a problem like this in the form of a multiple choice, I'm going to include the plus pi n plus pi n. Okay, so make sure you know how to condense it. Otherwise, it's like, hey, I did the problem, I just didn't know how to write it in a specific form. Okay.